Yeah, hello everybody. Quite quiet, genau. Yes, quite quiet weekend for us because maybe he's only playing golf over the weekend and therefore he had no time to do some crazy things. Yeah, we are more or less in the end of talking about the so-called neoclassical theory of international trade, mainly, yeah, developed starting, of course, with Ricardo in the 19th century and then until, let's say, in the midst of the 20th century. Yeah, and I am still left to explain something what I couldn't explain last week because I was a little bit puzzled. Of course, professor never makes mistakes. Um, Sometimes we say something wrong because of pedagogical reasons in order to see that you are still in class and you raise your hands. Well, this is wrong what you have said. Or in this kind, I have to admit that then if it's not a mistake, I would call it a blunder, and therefore you have maybe it already seen a minute ago. I put this chessboard for you online. Is somebody of you playing chess? Or at least you know how to draw the figures? Yep. Okay, so this is a very famous position in chess. It was 2006, and was Vladimir Kramnik. Well, he is not that famous as Magnus Carlsen, but he is a former world champion. And this was versus Deep Fritz. Do you know who is the guy, Deep Fritz? This is just a chess engine because this was maybe the last time a human being, or yeah, last time a human being has played really against, or a world champion has played against a chess engine. I think he lost in the end, or it was a draw. But after that time, now in chess you are rating people with the so-called ELO number, and Magnus Carlsen has maybe 2,900, and the best chess engines have about 3,300 or more. And 400 points means it's outward away. You have no human being has definitely no chance anymore to win against a chess engine. Well, what does has to does here has to do with our lecture, because if I didn't have made a mistake, then in chess, if you don't see something really obvious, then you call it a blunder. And here, Vladimir Kramnik, he played in this position Queen E3 as white. And maybe you see it, what would have been a better choice in this case. Still, you have to play with the queen, and maybe you know that the queen can play as far away as she wants in every direction. But of course, you have also to know how the other figures can play. Yes, of course, because yeah, because the knight it is called. No, I'm sorry. Because and therefore it is chessmate. He would have won this game against the chess engine. So what was my blunder? Well, I started here, especially that I said we start here with a relative price ratio P over PB prime, and then I said, okay, we are lowering this price ratio, and this would mean that the price ratio of our input factors would increase because of this decreasing dependence. And then we moved to the dependence between the price ratio of the input factors and the um, ratio of the quantities of the input. And there we argued that here we have an general for both goods, we have an increasing dependence. Well, and if this is increasing and we have an increasing dependence, then of course we should have also here an increasing of the ratio of the input factors. And now then in the lecture I switched to green and I just within the lecture switched the starting point. Because if you look at here, then I just said, well, let's assume now that the price ratio is increasing. Well, and then in the end, I was a little bit puzzled. I'm sorry for this, because I think that I also still had in mind that we decrease the price ratio, but I now just switched to an increase of the price ratio, and in the end, I didn't know anything where I was. But the mathematics and the dependencies, everything is okay. What we have done here, only I shouldn't have changed that I at first always argued we are starting what happens if the price ratio PA over PB is decreasing, and then arguing through the model, and in the end or in the middle I just switched to the situation. Let's now assume that the price ratio is increasing. Well, and for this I put it here, and then you can maybe a little bit easier follow the argumentation, what we have done. So let's assume we have a decreasing price ratio PA over PB. This would mean that the price ratio of the input factors is increasing. Remember this diagram here? Oops, this one, decreasing dependence between these two price ratios. And then this means that for both goods, we have an also increase ratio of capital over labor. This is just, oops, this diagram here. And then we were at the point that we also want to argue not only in these relative argumentation, but that they also, we have these effects on the weighting in, yeah, so to speak, real terms. Remember the specific factor model when we argued about what happens to the workers? And then we said, well, nominally we have a wage increase, but over proportionally good one was increasing even more, and the other good, the price we held constant. So then was the argumentation, well, I can now buy more of the good, which we have assumed to be constant in prices because my wages has nominally increased, but it's a pity I can now buy less of the other good, although my wage has increased because the increase of the price of the other good is more than the increase of the wage. And here we have then also now said, well, remember PA or good A was capital intensive. If PA over PB is decreasing, this means now we are favoring the labor intensive good because A is a capital intensive, B is a labor intensive, so the labor intensive good relatively increases the other way around. Here, the wage over interest. This means now, and this is so to speak the first step of the Stolper-Samuelson theorem, that now labor is favored, and this means that relatively the wage is increasing and relative to the interest. Well, so we are relatively quite happy, but still my good has relatively also increased in prices. And so I now want to know, well, I'm so to speak also somehow richer because I see more money on my banking account. But now I also want to know this, does this also mean that I am in real terms richer? And for this, I want to know my wage has increased. Am I now only able to buy more of good A and B? And for this, we then calculated the marginal products of labor and capital. And there we then calculated also the dependence of these marginal products with respect to the input ratio, K over L. And in the argumentation, we had relative prices, A over B, are falling. Input relative prices are increasing, and this means capital over labor is increasing for both goods. And we have derived that the dependence of the marginal product of labor with respect to the relative input ratio is positive because F double prime is negative, K is positive, this minus sign, minus times minus is positive, and marginal product with respect to the labor input, this is just F double prime, and the general assumptions about neoclassical production functions, this concave shape means, of course, second derivative is negative. And so we then take also our knowledge about economics. Why are we looking at the marginal products of these two input vectors? Well, from profit maximization, we know that the valued marginal products equal factor input prices. Remember, this is the very general condition for profit maximization. I asked myself, if I increase my production, This means I can sell more products. I can sell these products for a price which is given under fully competitive markets. So, and then the marginal product of an input factor is the additional production which I can sell at the market if I'm increasing this input factor. So this is the one part. This means I have a higher revenue price times the additional production. Additional production is represented by the marginal product. Well, what a pity. On the other hand, my costs are rising. I have to pay the new guy, for example. I have to pay for the new machine. And the price for the new guy is the wage, and the price for the new machine is the interest. So price, output price times marginal input equals input price. Well, and then I can just divide this. I can divide the input price by the output price, and this I have done here. See, I divided it by the output price. So the optimum condition in profit maximization I can also reformulate as marginal product of the input factor equals the real input price, because now I have my nominal wage, 2,000 euros per month, and now I divided this by the output price. So then I know how much can I buy, how many cars can I buy, how many chairs can I buy, how much liter milk can I buy. So this is, so to speak, the real price, real input price. Yeah, well, and now we can use these dependencies here to get our final argument in the Stolper-Samuelson argument. We know this is decreasing. This means capital over labor is increasing. We know that marginal product of labor is increasing in capital over labor, but this then means that also the real input price is also increasing because of the condition of profit maximization. So then in the end, I know that the labor intensive good sector will be now better off because wage over output prices are increasing. Well, and the other argument we have here, the marginal product of capital, the dependence on capital over labor ratio is decreasing, so we obtain the opposite direction. So, well, and then we are done with the Stolper-Samuelson argument, because now we have here that the intensively in the production of that good will increase, and on the other hand will reduce the real return of the other factor, and always in both goods. So this is then an other result compared to the specific factor models, because there, remember, we looked at the flexible input factor labor, and there in one, when the price ratio PA over BB has changed, then for the workers we had an ambiguous situation that they can buy in real terms more of one good but less of the other one. And here we have that the intensive sector will be better off in both sectors. Okay, then we are already in the summary of the Heckscher-Ohlin theorem. Let's go in the end to the overall effects. The Heckscher-Ohlin theorem and the Stolper-Samuelson theorem together imply that the owners of the abundant factor, not a surprising result, will gain from trade, and the owners of the scarce factor will lose from trade. And then this is the very main result in neoclassical trade theory, that we can also show that the winners, the benefit for the winners overall is larger than the losses of the losers. Remember, this is, let's say, in all three models, B, A, B, A, always the same picture. Ricardo, it was this one. This was the income line, outward shifted. And if we, since the slope of the income line in the Ricardo model is in between the slopes of the single transformation curves, let's say it looked like then like this and this, the single transformation curves, then we can move inward parallel our maximized income curve. And this would mean, remember in the Ricardo model, we were fully specialized. So the one producing here and the other one is producing here. Then we can shift this inward. So this would be then the, so to speak, single income line for both countries, and everything under these new income lines, which are in one spot, in the one country steeper and in the other country flatter, everything below these new income lines I can buy. And then in general, more is always better assumption for preferences means that I can shift my demand from my production point, maybe here and maybe here. And then we know, okay, I can choose a higher consumption level in my country compared to the situation of autarky, specific factor model. Now the pictures look similar. This would be autarky. Oh, oops. Production and demand are coinciding. Then let's say we obtain a steeper, we obtain a higher price ratio. Then we have a steeper income line moving to this. Trade, production, and then everything below the new income line I can buy. And then let's say this triangle here, there I can choose my new consumption basket of A and B, maybe here. And the assumption more is always better means I can choose more. Okay. And well, for Heckscher Olin C above. It looked like the same. Okay, and this I have put here. Well, and so to speak, the qualitative reason why is it always better to trade with each other, even if I not fully specialize, like in the Ricardo model. This means that production and consumption has now not anymore coincide. Well, and I think in order to be of the opinion that this would be in general a good situation when I am not always have to produce what I am consuming. Well, I think for this insight, mankind doesn't have to enter any lecture, that this would be maybe a quite good idea. I think this is one of the main drivers of development in mankind. Well, that I am not always have to go behind the tiger to have something to eat, that I not for my own have always to go to the lake, coming back with some water, that I have something to drink, that we say, well, here's a group going behind the tiger, here's a group going to the lake, let's meet 4 hours later and then have a meal together and let's drink together, that this is a reasonable idea to come forward. I think this is obvious. And think about this, these obvious things, these models, these things should be also be incorporated in good models. Because if the outcome of such a model would say something opposite to obvious things, then you don't have a good model, because what we are doing here, well, on Thursday we are doing the bad mathematics, but a good model is not about to have nice mathematical solutions, to have a very complex argumentation. A good model in economics is just to describe our own behavior. Then you have a good model. Yeah, and then look overseas. I think it was Friday night. I just switched on TV and then I saw a live statement of this guy overseas, and he was always talking about, well, and in the last 50 years 80,000 companies left the United States producing somewhere else. If I would have been in charge 40 years ago, no of these countries would have left our marvelous, beautiful country. They would be still here. All the guys would be employed at these companies. Why have they left these companies? Because of competition. Because of these argumentations, we can increase the choice for everybody when we are separating, but also trading, so trading together with of course, no limits or only low limits between the trade. Because of course, when you are specializing and then you have really limits of trade, then you cannot take the gains from the argumentation we had here. Well, I really say have fun in the United States. Well, you are the largest economy. It can work some years, but it is definitely not a good idea to go only to yourself. There are many, many good arguments, and I think just this sentence here is so obvious that I really cannot understand the US American people. Well, but we can look to ourselves 80 years ago. Do I have quite fast this picture? Let me think. No, I don't have it in the cloud. Or let me see. Let me see. Do I have it here? Up. No. Where is it? I think here I have it. Or Germany. Exports. No, but I later on, and maybe in 1 or 2 weeks, I will show you then this diagram. But then at this point, well, we had a time in Germany 80, 90 years ago where we had also the idea of fully decoupling from our neighbors, and think what was the reason that we are not depending anymore on our neighbor countries. I do not hope that this guy has the same ideas, but if he is talking about, well, Greenland is such a nice part of the world, let's move there. Actually, I don't know. And maybe when he is always firing dead animals still, so burning oil, burning gas, and so on, then of course you should look at areas which are right now quite cold, because in the future they won't be that cold anymore. Okay, anyway. So, and the last point, and this you also really keep in mind, this is together with this the main takeaway from neoclassical trade theory, that the argumentation, so to speak, the economic argumentation, why do we gain from trade, is this argumentation via comparative advantage, not absolute, comparative advantage. This is what it is about. Okay, so then before we start with the next topic. Oh, production. Because on Thursday we will go through the Heckscher-Ohlin model with the mathematics, and at first I had the idea only to do it and then later on switch to an exercise only to do it with a general production function. Just say we have f of k and l equals a and b. So our products a and b with df dk larger than 0, d2 f2 dk squared smaller, positive but decreasing marginal products, of course also for the other input factor L plus constant returns to scale. Well, this was now via the diagrams always our argumentation, and then we had this little part of mathematics when we calculated here the dependencies. Oops. Here the dependencies of the marginal products on capital over labor ratio. But then I thought, because this is, I think, quite abstract for you, when I'm doing this always and doing the math and then having always only these derivatives in the derivation, then I will do it parallel, so to speak. So at the one part of the slide, we just taking f of k and l, and on the other part in parallel, I will do it with the, so to speak, general production function which we are using in economics when we want to estimate something or when we want to show something in concrete. And this is the so-called constant elasticity of substitution function. This is the very general form I gave you here because this is x vector. These are the input factors. Because of course, in general, we have not only two input factors, we have many, many input factors. And so x vector is just x1, x2, up to some number, 50 or something else. But we will then use the two input factor version of this function. So this is then alpha, so the weighting of one of these inputs, and why I take here the exponent 1 over sigma, I explain in a minute, times k sigma minus 1 over sigma plus, and then I would take alpha 2 for labor input, but, and this you hopefully know from statistics, what this is nothing else than something like a general mean of all of my inputs. And to take just a general mean for a production function, this seems also to be a good choice, because what else is taking all the inputs and one good is coming out if I have a one product system. So then, in general, these production process somehow averages all incomes to obtain one good in the end. And of course, then we in general assume that the sum of all weights equals 100% in the end. Think of the weighted arithmetic mean, weighted geometric mean, what else? And therefore then the weight, if we have only two input factors, for the second input factor is just 1 minus the weight of the other one. Because if it's 1 minus alpha, then alpha plus 1 minus alpha is 1. Okay? So 1 minus alpha, 1 over sigma L, sigma minus 1 over sigma, brackets, and oh, yeah, no. And then just this ratio the other way around, the inverse of this ratio, exponent out of the bracket. Sigma over sigma minus 1. Well, this looks very, very complicated for you. When I have seen it the first time, it was also very complicated for me. Although I have studied physics and mathematics before my economic studies, there are many letters within this function. And even if you look at it, you think, why do I have to formulate this exponent so complicated? Let's call this, or let's give them just another letter, let's say A or B, then the function looks quite simpler. This is true, but this formula is formulated like this because then we can interpret this sigma in a very good economic way, because this sigma is then the elasticity of substitution between these two goods. So if we want to change something in the production process, and we assume that our production process is modeled with this function, then the elasticity, the relative exchange ratio of the two input factors is always constant. And this is a very nice property for a function. And therefore, we take this complicated form of these exponents. Remember, elasticities in general, do you remember how elasticities in general of x and y are formulated? Elasticities are maybe the most important numbers in economics. Not prices, but elasticities. Do you remember how an elasticity is defined? Think of price elasticities or something like this. I think you have already talked about in other lectures. Let's take a price elasticity. Price elasticity, there was a question behind: if I am rising my prices by 1%, how much in percent is the change of the quantity? Let's say demand. I think at least in microeconomics, but I think also in Introduction to Business Administration, you should have talked about this, because this is always about this. I should always think in my enterprise when I start to change prices. If I'm changing the prices, then of course I have to expect a reaction in quantity. Actually, then we are back again at this crazy guy overseas, because he also doesn't think about this general effect. If I am changing prices via a tariff, that then the quantities which are coming in my country will change. He always sits there and say, well, let's take 100% tariff on Chinese products. Then I'm earning that much. Well, what a pity. If then imports are falling over proportional by more than 100%, what happens? The revenue from tariffs will decrease, although I have increased tariffs. And he is definitely not thinking about this because he always argues only in this very simple and I have to say really stupid way. He doesn't know how people react. So, elasticity is then the relative movement. Price elasticity was the change of x via my starting point divided by the price change. So if this is changing by 1% prices, how much in percent is then the change of x, or in general delta x over delta y over y. Here again, relative concept. Actually compare this to comparative advantage. Again, we have a relative concept. And why do we have always these relative concepts in economics? Remember, I have talked about this 15 minutes ago. What do we want to do with all our theory? We want to explain our own behavior. And what is the main assumption? I do not want the assumption about a Homo economicus. What is the overall main assumption? How do we model in economics social behavior? What is the very main concept we are using? Actually, this is always the starting point. You could always say this is the starting point when you are somehow argue in an economic way. We don't talk about this anymore because we say, well, it's clear that this is a starting point. Yeah, well, this is then the assumption for the Homo economicus. Thus, we have our preferences at that we are utility maximizer. Well, this is also very, very general, of course. But I think there's even a more general thing. How do we start this process to come into the maximum, our aim? You are comparing alternatives. You have a budget of time, you have a budget of money, you have some resource constraint, and then you have alternatives. What can I do with my things I have? And this is the concept of opportunity cost. Then I value these alternatives relative to each other, and then I argue when then I have my choice, I'm coming at this very nice weather day into the lecture hall, not sitting outside and eating an ice. Then I am value sitting here, hearing, listening to this crazy professor. Well, this is marginally more preferable for me than sitting outside and having an ice. But then sitting here is the utility you have lost not sitting there and eating this nice ice. This is also then a relative concept. So opportunity costs. And we have talked about this. We have introduced comparative advantage, just that this is that this comparative advantage is just opportunity costs. In Ricardo model, it is just we have two alternatives, producing good A, producing good B, comparing when I'm producing 2 units of A, I have to reduce the production of B by, let's say, 4 units or something like this. Relative costs of producing 2 of A is 4 of B. Yeah, and then I will do all the mathematics on Thursday of these Heckscher-Ohlin model, and it is just a general equilibrium model. Of course, you can then apply all of this concept on two-sector production within your country, 2 markets, whatever you want. And we will do it then with this CES function. And therefore, I would recommend that you just look at the derivatives of this function at home, that you not just see it on Thursday when I'm starting. Then, because then maybe you are already after 5 minutes lost. And this would be a pity. So, at home, df, so this is then our general f of k and l. This is then homework, df, dl, df, dk. And what also we need then, since we have constant returns to scale, look at it that you can show that this function, very complicated, exhibits constant returns to scale. So show CES has constant returns to scale. What do we have then to do? You just have to interchange your k with lambda k and L with lambda L. And then somehow, hopefully you have done something like this in your introductory courses in mathematics, that somehow this lambda moves out of the bracket. And hopefully you find then that if this is outward of these brackets, that this lambda has then some exponent, which is hopefully just the inverse of this exponent, because a variable x to the power of alpha to the power of 1 over alpha is x alpha times 1 over alpha is then x itself. Well, actually, you know that this will be the result, but also one has to show this. Because when we have then shown this, then we assume that lambda is 1 over L. And this you also can do. And then remember this we have already done here in general when we just assume that we have constant returns to scale. Then we can in general show that this is the case, that then we moved to a function only depending on these labor input ratio. So this then means when we assume this, then when we just look at all our variables just relative to the population size, then we go to f of kl will be then a function L times f only of one variable, and this is now this relative variable k over L. Because then we also have to know how looks this small f of small k when we are starting with the CES function. How does the new function, which is now only depending on this input ratio. How does this look like? Why do we need this? Well, we need this because then in the end, to show the end of the Stolper-Samuelson theorem, we have to calculate the derivatives of this function f of small k. Yeah. And then, yeah, also then f prime of k we need, and we need also f double prime of k. So what should you also, what overall you should do? Take this function, please calculate this derivative. That will take time. Yeah, you have to use chain rule, I think 3-4 times in a row, and do it really careful. And I really recommend this. Take just oops, this one. There's nothing here. And then you can just, for example, say d dx of x squared minus 5 over square root of x minus 5 over x. So I don't think that you can do it in your head. I can also only do it just in my head. It would take some time. Hopefully all my brackets are closed in the right things. Yes. And there you have your derivative. So type this test function carefully in, for example, Wolfram alpha, and then you can see if we can go here. Then if you then you can see that your calculation by hand was right. And of course, if you type a derivative of this function just in Google, you will also hit at the first 2 points the result. But I really recommend that you do it also by hand by your own. And yeah, why do we use this? Not only because of this constant elasticity of substitution, this is also a very general function, and putting some specific numbers for sigma, then we can show that for sigma equals 1, there you have to take some limits because you are dividing here by 0, putting 1 for sigma, but then you can show that the limit is existing. So then it is our well-known Cobb-Douglas. This would be k alpha L minus alpha, or sigma is 0. Although then you have to take here a limit. Then you are at perfect complements. No, this one is Cobb-Douglas. And if you, let's move sigma to infinity, then you can show that you have perfect substitutes. So all utility functions, production functions you have already seen in your studies, they are all incorporated in this function. And therefore, this is, so to speak, the working horse of econometrics, of quantitative calculations in economic theory. And therefore, it is quite good if you are able to handle this function. Not only saying, whoa, no, this is too complicated. Move away. I only want to have square root of k and l. So 99% of all economic exercises which you should calculate and where you have to model neoclassical production, you will find square root of k times l. Well, square root of k times l is just Cobb-Douglas with alpha equals 1/2. Well, this is a very reasonable production function because why? This is a geometric mean of k and l with the same weights. Both weights are 50%. Why do I not choosing the maybe simpler perfect substitutes k plus l? Well, remember the gravity model. There we had also the argumentation. In the denominator, we had it y1 GDP of one country times the GDP of the other country. What was the argumentation? The argumentation was a large country trading with a small country. If we choose the sum, then we more or less do not see the small country because US plus Luxembourg is still more or less the GDP of the United States. Well, and Cobb-Douglas, taking here the multiplication of these two input factors also means, well, this just means you always need, if you want to produce both factors. If you have perfect substitutes, you can also produce only with one factor. If you have a multiplication, then this just means here I have the situation in production where I always need both factors because 0 times the other factor is still 0. So putting these functions doesn't mean that we want to make you angry. This is just a reasonable choice to model production. And this is then a reasonable general choice to model production. So please do it. I think if you have then also this derivative having shown constant returns to scale. So this would be 1, 2, constant returns to scale 3. Then showing how looks like small k by setting lambda to 1 over L would be 4 and 5 and 6. Maybe this afternoon or tomorrow afternoon or in the evening. I think you should be able to do this in 1.5 hours. But this would be the time. I think you haven't done this. You haven't done calculations right now with the CES function, or no? Okay. Okay. What else wanted I do? No new topic today, but I am just in the organizing process that I have talked to Dr. Jörg Rahn and Dr. Wolfgang Kornprobst, and Jörg Rahn is Chief Investment Officer of an investment company and of the so-called tertium family offices. So, and family offices, do you know what family offices in finance in Germany are? Or these are just the guys who are paid by the very rich families. The very rich families have, let's say, I think the richest in Germany is, I don't know, Lidl, Mr. Schwarz from Heilbronn, I think, with around 40 billion or something like this. Well, and then he says, or this family says, well, let's take half of it, 20 billion, go to the financial markets and invest it. And yeah, Wolfgang Kornprobst, he is right now working to Siemens. I asked him just 3 weeks ago and nothing, no feedback from him. And then last week I sent again an email, nothing. And yesterday I got my feedback. And what was his explanation? Well, we are really have much work right now. Siemens, one of the largest international companies in Germany. And if you take the times right now, then you could think that they have lots of work. What are we doing? And yeah, so this is then, I don't know if this will be the title, but this was my idea. De-risking, decoupling, what happens in international trade, what are you are doing if you are at the financial markets or if you are working in an international company. Well, both are general economists. And then I want to go to you with you to the Jade port. I think this will be also interesting, especially in these times. What happens to international trade looking at the harbor here in Wilhelmshaven. And well, we will see. It will be both on Thursday, 15th or 22nd. I don't know when will be when. This will be next week or the week after Easter. I can say it to you. Especially in the Moodle course, there I will make a survey where you can say I'm interested to come to the Jade port. Because there I have to announce we have also to charter a bus and so on. Okay, so no new topic today. It's, yeah, this was more or less a live idea to talk today about something else. Hopefully this was also interesting. And yeah, please do the math at home or try it at least. Then, thank you very much for today.